Welcome back. Last time you were here, we learned about addition, and we showed it with the dot and box method, and we worked really hard to get this mathematical fact of 432 plus 194 is 626. Okay, well the lesson today is subtraction, so can I write this sort of statement using the verbiage of subtraction? And I think the answer to that is yes, so it's another way to say what's kind of going on here, but using the language of subtraction. An equivalent statement to this, it kind of tells me the same thing. If I have 626 and I take off the thing that was added to 432, so the thing that was added was 194, if I take that off, I should get back to where I started at 432. So these are related facts. And I was only able to write this fact because I knew this original fact, right? So let's suppose I didn't know this. So that previous lesson out the window, right? Hopefully still remember something about addition though. And let's pretend then that I don't know this answer, right? Because I couldn't know that. I'm just presented with this new subtraction problem. All right, I think hopefully many of us have encountered this in grade school. And even more hopefully that maybe we remember how this goes. So I have 6 things and I take off 4. Okay, if I have 6 things and I lose 4, I'm left with 2. Cool. All right, now if I have 2 things and I take away 9, I can't really do that, right? I can't have 2 things and lose 9. And we were taught at an early age, okay, to look next door, make that 1 lower, and then put a 1 right there. And a lot of times that's the extent of how it's explained to us. You know, if you're out of room, right, you don't have enough steps to take away what you need to, just look next door, drop it down by 1, and you get a little 1 there. And so now it's 12, take away 9. Okay, we can handle that, that's 3. And 5, take off 1, that's 4. Oh, hey, that was what I was predicting, right? But I don't think a lot of deep understanding happened there. Like, what did that 6 do? He only dropped down by 1, and this went up by 10. And even those things I just said, I don't know if everyone totally gets that this went down by 1 and this went up by 10. Sometimes I just think like, oh, a little 1 got put there. So let's kind of deeply investigate this and see what's going on, so that way we have the ability to really carefully explain it to students that might have questions about why is that how it works. You can't just say that's the rules, right? You should be able to explain why the rules are in place. So I'm just writing 626 in dot form. And I'm supposed to be ticking off 194. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 4. 1, 2, 3, 4. Okay. So what does this mean? It means like if I have this many berries, right, I'm going to look 1 column at a time. And I have to give away this many, right, or they get taken away. What's left, right? So I'm taking off this much. And so it's kind of hopefully clear to see in this rightmost column, if I have this many dots and I take off that many, I could just kind of erase them and see that this is what's left behind. Cool, pretty straightforward. Now I have to play the same game here, and a lot of times I need to take this amount off of that. And a lot of times students will go, oh, I can't do that, right? That's too many things to take away. And they'll say, oh, I got a solution. How about I just take that off of this and instead just flip it around, right? And get 7. That's a common mistake. But we can't do that. So yes, there is a problem. And the solution isn't just to make up rules and flip things over and do 9 minus 2 instead of 2 minus 9. We still have this issue, right? I only have 2 dots and I'm supposed to take off that many things. How can I do that? Well, remember that this is part of this entire number. So he's got some wiggle room in a sense. I can rewrite this in a way. So I wish I had more dots here. And maybe when we started the number in the rightmost column, once upon a time there were more dots here before they got put into that place. So I can think about that fact. If I were to take 1 here and kind of do the opposite motion of carrying, but I'm actually it's called borrowing, but I'm not really borrowing because I'm not giving it back, right? But I take 1 away from here, and if I lose 1 in that position, how much is it worth back here? So I lost 1 here, but what did it originally look like if it had to be written in this box? It's 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the loss of 1 here means that it was worth is the same as having 10 here. So 1 here is the same as 10 here. And that kind of hopefully makes sense with our idea of like dots and boxes of moving things over. So if I had a group of 1 here, it was originally worth 10 in base 10. So if I take 1 off here and want to represent it in this next over box, it's actually worth more there. So in this sense, I can lose 1 group of, it's in the hundreds place. So 1 group of 100 is the same as 10 groups, because that 2 turning into 12 is adding 10. It's the same as 10 groups of 10. So 1 group of 100 is the same as 10 groups of 10. So that's kind of like me talking about that mistake, right? Someone might think that this Instead of this being the answer, maybe they think it's this, 5, 1, 2, 6. We talked about that last time. And that's sort of what we're going to use here. If we take 1 away in this position, it's worth 10. Okay, I think I beat that over the head a little. So I have 10 plus 2 more, now I have 12. That makes sense where I got that 12 from. And I'm losing 9. So if I erase 9 off of here, hopefully you're convinced that you can get 3 as a result. So if I now have enough dots, thankfully, because I took some help from my next door neighbor, right? And I made it 10, because 1 here's worth 10 there. I can take off 9 now, because I have plenty to take off. Plenty of room to take this off. Okay, so this, I took over that challenge, and now I've got one less friend here, but he really helped me out here. So now I have 5, take off 1, 1, 2, 3, 4, and you can see the answer being 4, 3, 2. And you can really see that borrowing happen. So what happened over here is what's happening over there just algebraically. And hopefully with this picture in mind, you can better explain what's going on here. Okay, thank you.